In this video, we want to compute this triple integral of x, y, z squared dv over the region B. The region B is a rectangular prism, or a box, with these boundaries. So I'm going to sketch the region. I'm just going to sketch a box, and then we'll label what the boundaries are. So here's and by the way, it's not necessarily to scale, but this is the region B that we want to integrate over. And we are told that in the x direction, the bounds are from 0 to 1, so the x-axis is this direction. So this is 0 to 1 in the x direction. In the y direction, the boundaries are -1 to 2. So this is -1 to 2 in the y direction. And then in the z direction, the boundaries are from 0 up to 3. Okay, and so this is our y, our x, and our z. Because this region is a nice rectangular prism, then we can break up our integral, and we can write our integral as triple integral over the region B. X, y, z squared dv. Okay, but again, because it's a nice rectangular prism region, this can be broken up into the integral from 0 to 3, integral from -1 to 2, integral from 0 to 1, x, y, z squared, dx, dy, dz. And at this point, this integral is what we call separable. So the three components of the integral can be separated, and we can just compute this as the integral from 0 to 3 z squared dz times the integral from -1 to 2 y dy times the integral from 0 to 1 x dx. And of course this becomes, do each one individually, 1/3 z cubed, as z goes from 0 to 3, times 1/2 y squared, y goes from -1 to 2, times 1/2 x squared, x goes from 0 to 1, and we just plug all these in. So this one becomes 9. This one is 2 minus 1/2. So that's going to end up being 3/2. And this one is just 1/2. And so at the end of the day, this product is 9 times 3/2 times 1/2. So this is 27/4. And so a triple integral over a rectangular prism or a box region, especially when the integrand is a product of functions of x, y, z, can just be broken up and treated like three integrals in the Calc 1 sense.